You probably think you know dinosaurs. After all, they've been in movies, books, and documentaries for decades. But here's the thing, almost everything you think you know about these prehistoric giants is wrong. And I'm not just talking about small details. I mean fundamental facts that completely change how we see these creatures. Take the most famous dinosaur myth of all. The T-Rex had useless arms. Those tiny arms could actually lift 400 pounds. That's right, enough to bench press 3 adult humans. But if you think that's mind-blowing, wait until you hear about the myth that fooled even scientists for over 100 years. These are 15 dinosaur myths that you still believe that are absolutely false. If you love dinosaurs and want to learn more about them, make sure to like this video and subscribe. When you picture a dinosaur, you're probably imagining something the size of a house. But what if I told you that some dinosaurs were smaller than your pet cat? In fact, one of the most successful dinosaur species was no bigger than a chicken. And that's just where it starts to get really interesting. Here's the fun experiment. Ask any kid to draw a dinosaur, and chances are they'll sketch something massive. And who can blame them? We've all grown up with images of towering Brachiosaurus and building-sized T-Rexes. But here's the thing, focusing only on the giants is like saying all modern mammals are elephant-sized. The truth is, dinosaurs came in an incredible range of sizes. While Argentinosaurus could reach lengths of 130 feet, that's longer than 3 school buses by the way, some of the most successful dinosaurs were downright tiny. Take the Compsognathus, for example. This little predator was only about the size of a turkey, but it dominated its ecosystem for millions of years. That's longer than humans have even existed, by the way. This thing lived longer than us. That's pretty impressive. These smaller dinosaurs weren't evolutionary dead ends or failed experiments from nature. They were incredibly successful, often outlasting their larger cousins. Think about it. When food became scarce or environments changed, which would have better survival odds? Something that needed hundreds of pounds of food per day, or something that could get by on just a few insects? In fact, some scientists now believe that these smaller dinosaurs were actually the norm, not the exception. The giants that we're so familiar with might have been the unusual ones. Kind of like how elephants and giraffes are amazing, but definitely are not your typical mammals like your cow or your horse. But if you think dinosaur size will blow your mind, wait until you see how they actually move, because that tail-dragging lumbering lizard that you're picturing in your head, I'm about to shatter that entire reality. Every classic dinosaur movie shows the same thing. Giant reptiles dragging their tails through the dirt like living bulldozers. But here's the wild part. We've never found a single fossil trackway showing tail marks, and the reason why changes everything we thought we knew about how dinosaurs move. You know the image of Brontosaurus plodding along, tail scraping the ground behind it? Turns out that's about as accurate as showing elephants crawling on their bellies. But don't feel bad. Even scientists got this one wrong for nearly a century. The breakthrough came when paleontologists started looking at dinosaur tails differently. They weren't just dead weight, they were precision engineered balance beams. Take the Velociraptor's tail. It was basically a carbon fiber rod made of specialized tendons and bones, held perfectly horizontal and stiff as a board. Why? Because it acted like a counterweight, letting them make sharp turns at high speeds without wiping out. But here's where things get even more interesting. Those giant sauropods, like the Diplodocus, their tails were basically biological bullwhips. The vertebrae in them got progressively smaller towards the tip, creating a natural whip structure that could actually break the sound barrier when snapped. Imagine being a predator and hearing a sonic boom from your intended prey. And the T-Rex, its tail was essentially a massive stabilizer, like a rudder on a ship, helping it pivot and turn despite its massive head. Without that perfectly balanced tail, it would have face planted every time it tried to chase something. The evidence is literally set in stone. Fossil trackways from all over the world show footprints with no tail marks between them. These weren't clumsy lizards. They were more like Olympic gymnasts, using their tails for perfect balance and explosive movement. Speaking of movement, forget everything you thought you knew about dinosaur speed, because that scene in Jurassic Park where the T-Rex catches up to the Jeep, turns out that wasn't Hollywood exaggeration, because some dinosaurs were even faster. Yeah, Hollywood actually had to slow the dinosaur down, because the real speed of these prehistoric predators would have made that chase scene end, well, let's just say much quicker. When we think fast, we think cheetahs hitting 70 miles per hour. Now imagine something the size of a bus moving nearly that quickly. Carnotaurus, with its ridiculously tiny arms and massive legs, could sprint at speeds up to 35 miles per hour. That's faster than Usain Bolt, and this thing weighed as much as a rhino. But speed was just part of the story. These these weren't just fast in a straight line, they were agile too. Take Velociraptor. Thanks to its specialized tail and lightweight build, it could turn on a dime at full sprint. We're talking about a predator that could change direction faster than a professional soccer player. Even the big guys weren't the lumbering giants we once thought. New studies of T-Rex leg muscles show they were built more like turbocharged power lifters than slow reptiles. Their leg muscles could generate enough force to crush a car, and that's not an exaggeration, that's actual calculated force. Here's the really mind-blowing part though. Some smaller dinosaurs like the compy we talked about earlier could hit speeds of up to 40 miles per hour. That's nearly highway speed, and they had a maneuverability to match. Imagine a turkey-sized predator that could outrun a motorcycle through a forest. But the best evidence? Fossilized trackways showing dinosaurs in full sprint. We can actually calculate their speed from the spacing of their footprints. And let me tell you, these weren't just casual strolls. They were full-on Olympic sprints that would leave modern animals in the dust. But if you think their speed is impressive, wait until you hear about when they actually lived. Because the classic image of cavemen fighting dinosaurs, the real timeline is going to make your head spin. If you've ever seen a movie showing cavemen battling the T-Rex, I've got some bad news. Those humans missed the dinosaurs by about 65 million years. That's not just a small gap, by the way. It's such a large time gap that the human can barely process what that actually means. But to break it down, we gotta put this in perspective. You know the pyramids in Egypt? They're about 4,500 years old. Ancient, right? Well, if the entire history of Earth was a 24-hour clock, humans would show up at 11:58 p.m. The dinosaurs, they ruled from about 2 p.m. to 11:40 p.m. We literally missed them by 18 minutes on this cosmic clock. And here's the really wild part. When you find a T-Rex fossil actually closer in time to that T-Rex than the T-Rex was to Stegosaurus. Let that sink in. There's about 83 million years between Stegosaurus and T-Rex, but only 66 million years between T-Rex and us. But don't feel too bad about missing the dinosaurs, because technically you're looking at one right now. That chicken sandwich you had for lunch, congratulations, you ate a modified dinosaur. Birds aren't just related to dinosaurs, they are dinosaurs. They're the only surviving members of the theropod family, the same group that gave us T-Rex and the Velociraptor. The evidence is literally in their bones, from hollow skeletons to wishbones, from scaly feet to laying eggs. Birds aren't just distant cousins of dinosaurs, they're their direct descendants. That pigeon outside your window, it's actually got more in common with T-Rex than T-Rex had with the Brontosaurus. But speaking of things we're all getting wrong, let's talk about what actually killed the dinosaurs, because that asteroid you've heard about, it wasn't working alone, and the real story is way more explosive. Everyone knows about the asteroid that killed the dinosaurs, but here's what they don't tell you. Earth was already trying to kill them with the largest volcanic eruptions in history. The asteroid, that was just the knockout punch in what might be the worst 1-2 combo in Earth's history. Picture this, you're a dinosaur living your best life 66 million years ago. Things are already getting rough because volcanoes in modern day India are erupting on a scale that makes Mount St. Helens look like a science fair project. We're talking about lava flows that could cover the entire United States in 600 feet of rock. Not exactly a great time to be alive, honestly. These weren't your typical volcanoes either. The Deccan traps were pumping out enough carbon dioxide and sulfur to turn Earth's atmosphere into something that would make Venus jealous. Temperatures were swinging wildly, acid rain was falling, and the air was getting harder to breathe. And then, just when things couldn't get worse, 5 big booms later, an asteroid the size of Mount Everest slams into Earth at 45,000 miles per hour. The impact was so powerful it sent chunks of Earth flying into space. Some scientists think it hit with the force of 10 billion Hiroshima bombs all at once. But here's the really crazy part. Some dinosaurs actually survived both of these extinction level events. Not the big famous ones, mind you, but the small feathered dinosaurs that could fly and adapt quickly, they made it through. We call them birds today, and they're living proof that life finds a way. Because speaking of survivors, let's talk about everyone's favorite gentle giant, the Brontosaurus. Because not only did it survive extinction once, it actually came back from scientific extinction too, and the story of it is absolutely wild. If you're older, you might remember when scientists told us when Brontosaurus wasn't a real dinosaur. Well, plot twist, they were wrong about being wrong. In what might be paleontology's greatest comeback story, this iconic dinosaur fought its way back from scientific extinction. And this story is better than any Hollywood script. The whole mess started with what historians call the Bone Wars, basically the most dramatic scientific feud of all time. Two paleontologists, Marsh and Cope, were so desperate to outdo each other, they resorted to fossil theft, spy networks, and even dynamiting dig sites to keep their rivals from getting specimens. I'm not making this up. This actually happened. During this fossil frenzy, Marsh discovered two massive long-necked dinosaurs. He named the one Apatosaurus and the other Brontosaurus. But in 1903, scientists decided that they were actually the same dinosaur. And since Apatosaurus was named first, Brontosaurus got erased from the history books. Case closed, right? Well, not so fast, because in 2015, scientists decided to settle this debate once and for all. They looked at over 477 physical features across 81 different dinosaur specimens. That's like doing a DNA test on an entire family tree. Turns out Brontosaurus was different enough to deserve its own name. After all, the differences might seem small to us. Slightly different neck vertebrae, unique hip structure, but in dinosaur terms, these were major distinctions. It's like telling the difference between a lion and a tiger. Sure, they look similar, but they're definitely not the same animal. After more than a century of scientific exile, Brontosaurus is back on the books. Not bad for a dinosaur that supposedly never existed. But speaking of things we got wrong about dinosaurs, let's talk about their blood. Because that whole cold-blooded reptile thing, well, new evidence suggests dinosaurs had more in common with birds than lizards, and it completely changes how we see them. Imagine being told that everything you know about dinosaur biology is wrong. Well, that's exactly what happened when scientists examined dinosaur bones under a microscope, because these cold-blooded reptiles had something in their bones that only shows up in one type of modern animal: warm-blooded birds. For years, we pictured dinosaurs as oversized lizards, basking in the sun to warm up like modern reptiles. It makes sense, right? Big, scaly, reptilian-looking creatures must be cold-blooded, but here's where science throws us a curveball. Dinosaur bones tell a completely different story. See these tiny channels running through the bone? They're called haversian canals, and they're like tiny blood vessel highways. Modern cold-blooded animals have very few of these, but dinosaur bones, they're packed with them, just like modern birds and mammals. This isn't just a cool fact, it's a smoking gun. Think about what this means. A warm-blooded T-Rex wouldn't need to wait for the sun to heat up before hunting. It could chase prey at night, in the rain, even in cooler temperatures. Suddenly, these predators become even more terrifying. They were basically running their own internal furnaces 24/7. But it gets better. Some dinosaurs might have even been warmer than modern mammals. Scientists found evidence that some sauropods ran hotter than a bird's body temperature. We're talking about walking furnaces that could heat up a room just by standing in it. And those feathers we keep finding on dinosaur fossils, they weren't just for show. They were insulation, helping these warm-blooded creatures maintain their supercharged metabolism. Think of it just like your winter coat, but it's way more prehistoric. But if you think warm blood was dinosaurs' only surprising feature, wait until you hear about their skin, because those scaly monsters that you're picturing, many of them were actually covered in something that would make them look like giant chickens. If Jurassic Park was scientifically accurate, those velociraptors would have looked like murderous turkeys than giant lizards. And T-Rex, picture the most terrifying chicken you've ever seen, but the size of a bus. Welcome to the fluffy side of dinosaurs. The revolution started in China. 1996, paleontologists discovered a dinosaur fossil so perfectly preserved you could see every detail of its body covering. But instead of scales, they found something shocking: feathers. Not just a few, but a full coat of them. This wasn't some weird one-off either. Since then, we found over 50 different species of feathered dinosaurs. And these weren't just bird-like feathers either. Some dinosaurs had primitive proto-feathers that looked more like fuzz or hair. Others had full-on quills. The Velociraptor, it had arm feathers so well developed they looked like wings. But here's where it gets really interesting. We found evidence of feathers on some pretty unexpected dinosaurs. Even some T-Rex relatives might have had feathery covering when they were young. Imagine a baby T-Rex covered in fuzzy down, like some nightmare version of a baby chick. The colors weren't what you would expect either. Thanks to new technology, we can actually determine dinosaur colors from fossil feathers. Some were iridescent, like hummingbirds. Others had complex patterns and stripes. These weren't dull, gray lizards. They were as colorful as modern birds. But if you think feathers make dinosaurs less intimidating, wait until you hear about their intelligence, because those tiny-brained lizards were actually smarter than you might think, and some could give modern animals a run for their money. Remember that scene in Jurassic Park where the raptors figure out how to open doors? Turns out that might not be as far-fetched as we thought, because new research shows that some dinosaurs were smarter than dolphins, and one species in particular might have been as intelligent as modern primates. Meet the Troodon, a dinosaur with a brain-to-body ratio that would make some modern mammals jealous. When scientists first calculated calculated its intelligence quotient, they had to double check their math. This turkey-sized predator packed more processing power than any other dinosaur we've found, and it's changed everything we thought we knew about prehistoric intelligence. We found evidence of complex social behavior that would put some modern animals to shame. Maiasaura, whose name literally means good mother lizard, built massive nesting colonies and cared for their young for months after hatching. They even had dinosaur daycare centers. Seriously, we found fossil evidence of adult dinosaurs watching over groups of juveniles while others went foraging. And those dumb plant eaters, turns out they were running some pretty sophisticated operations. Hadrosaurs had complex social hierarchies and used their hollow crests as natural trumpets to communicate across miles. Think about that. Dinosaurs had their own built-in social media network. The real mind blower comes from pack hunting dinosaurs though. We found evidence of coordinated hunting strategies that rival modern wolves. Multiple sets of trackways showing raptors working together to take down larger prey using tactics that require planning and communication. These weren't mindless killing machines. They were prehistoric special forces. Wait and see here about their swimming abilities, because that whole dinosaurs couldn't swim argument, we've just found something that completely changes the game. Imagine a 50-foot predator that hunted like a crocodile but could chase you on land like a T-Rex. Meet the Spinosaurus, the first confirmed swimming dinosaur, and the story of how we discovered its aquatic lifestyle reads like a Hollywood thriller. The story starts with a German paleontologist in Egypt, 1912. He discovered the first Spinosaurus bones, shipped them to a museum in Munich, and then World War II happened. Allied bombing destroyed the specimens, and for decades, Spinosaurus remained a mystery. That's just the beginning. Fast forward to 2014, when scientists found something bizarre in the Moroccan desert, Spinosaurus bones with dense walls, like those in modern penguin bones. Why would a dinosaur need heavy bones? Simple, to stay underwater. This wasn't just some dinosaur that occasionally splashed around. This was a genuine swimming machine. But here's where it gets wild. Spinosaurus had a massive sail on its back, paddle-like feet, and a crocodile-like snout packed with pressure-sensitive organs. Imagine combining a crocodile, penguin, and a sailboat, then making it bigger than a T-Rex. This thing was built for hunting in rivers and could probably outswim an Olympic athlete. But Spinosaurus wasn't alone. We found evidence of other dinosaurs that were comfortable in water. Some hadrosaurs had webbed feet and tails perfect for paddling. Even T-Rex might have been a decent swimmer. Computer models show it could have used its massive tail like a crocodile's to power through the water. If you think swimming dinosaurs are impressive, you need to hear about bringing them back to life. Because while Jurassic Park got the cloning part wrong, scientists are working on something even more mind-blowing. But sorry, Jurassic Park fans, the mosquito and amber trick won't work. Scientists are actually trying something way cooler. They're not cloning dinosaurs. They're reverse engineering them from modern birds. And they've already made a chicken with a dinosaur face. That's just a joke, but let's start with why the amber method is impossible. So actually, I did more research on this topic. This isn't a joke. They accidentally were able to do this. Here's the picture of it. That is crazy. DNA has a half-life of about 521 years, meaning after just a few million years, it's completely unusable. The youngest dinosaur fossils are 66 million years old. Do the math and you'll see why finding intact dino DNA is about as likely as finding a unicorn riding a dragon. But scientists aren't giving up. Instead, they're getting creative. Birds are living dinosaurs, and their DNA still contains ancient genetic code that's usually turned off. By activating these dormant genes, researchers have already created chickens with dinosaur-like snouts instead of beaks. Here's where it gets really wild though. Scientists have identified the genes that gave T-Rex its famous arms, Stegosaurus its plates, and Triceratops its horns. They're all still there, hidden in bird DNA like a prehistoric blueprint. It's like having the source code for dinosaurs right in front of us. But before you start planning your dinosaur theme park, there's the catch. We can't just flip a switch and turn a chicken into a T-Rex. That would be ridiculous. The process is incredibly complex, and we're still years away from creating anything that looks like a proper dinosaur. Plus, there's the whole ethical debate about whether we should even try. I think we should because it would be kind of cool and funny, but I can see why you wouldn't want dinosaurs alive again. Speaking of the T-Rex though, let's talk about those famous tiny arms, because new research shows they weren't just useless appendages. They were actually powerful enough to bench press a car, and the reason why will completely change how you see this legendary predator. Everyone loves to laugh at the T-Rex's apparently puny arms, but here's the thing, they weren't puny at all. Each arm was about 3 feet long and packed with enough muscle to put a bodybuilder to shame. We're talking about biceps bigger than your torso, connected to bones thicker than a professional wrestler's leg. But why would evolution give T-Rex such powerful arms while making making them so short? Turns out it's all about specialization. Just like humans in their careers and mine for eating too much Kraft dinner, think of them like nature's version of brass knuckles. They weren't for reaching, they were for close combat damage. When you've got a bite force that can crush a car, you don't need long arms. You need strong ones. Here's where it gets really interesting though. Those arms had another trick up their sleeve. They could rotate almost 360 degrees, like a socket wrench. Combined with their massive strength, that means T-Rex could grab prey and twist with enough force to rip off chunks of meat. Not so useless now, right? Recent studies of T-Rex arm bones show they were covered in deep muscle scars, meaning these arms saw serious action. Scientists now think they might have been crucial for something we never considered. Mating. Those powerful arms could have helped T-Rex hold on to their partner during, we're just going to keep this video family friendly, but you get the idea of what I'm talking about. But if you think the T-Rex arms are misunderstood, wait until you hear about the Stegosaurus's brains, because that whole second brain thing you've probably heard about, the truth is even stranger. For years, scientists thought Stegosaurus had a second brain in its butt. Yes, you heard that right. And while that turned out to be wrong, the real story is even more fascinating, because what they actually found changes everything we know about dinosaur survival. Picture this, you're a paleontologist in the 1800s staring at a Stegosaurus skeleton. You've got this massive animal with a brain the size of a hot dog, but there's this weird cavity near its hips that looks suspiciously like a second brain case. Naturally, you think, aha, two brains, makes sense, right? One brain for the front, one for the butt. Every other animal has that, right? But here's where modern science drops a plot twist. That second brain wasn't a brain at all. It was something called a glycogen body. Modern birds have them too, and they're basically biological battery packs that store energy for when times get tough. That glycogen body might have been what helped Stegosaurus survive in environments where other dinosaurs couldn't. Imagine having a built-in emergency food supply that could keep you going for weeks. It's like carrying around a backup generator in your spine. And the location wasn't random either. Having this energy storage near its hips meant Stegosaurus could power those massive leg muscles and that famous tail weapon, the Thagomizer. Yes, that's its real scientific name, and yes, it was named after a Far Side cartoon. Sometimes science has a sense of humor, even if it's terrifying. But speaking of weapons, let's talk about its defenses, because the plates on the Stegosaurus's back, they weren't just for show. They were high-tech temperature regulators that gave it a serious survival advantage. For years, everyone assumed those massive back plates were shields. I mean, they look like armor, right? But here's the thing. They were too thin and brittle to stop an attack. What they were actually packed with was something much more interesting. Blood vessels. Lots of them. We're talking about a network so dense it would make your circulatory system look simple. These plates were basically prehistoric radiators. When Stegosaurus needed to cool down, it could pump blood into these plates, where the large surface area would help release heat. Just like your car's radiator. Need to warm up? Just angle those plates towards the sun like solar panels. It's the same principle that helps elephants use their ears to regulate their temperature. But here's where it gets really clever. The plates weren't just for temperature control. They could also flush with blood to create a dramatic display. Imagine a Stegosaurus turning its plates bright red to intimidate rivals or attract mates. It's like having built-in warning lights and air conditioning. It's basically the earliest version of a Ford F-150, except far more deadly. Scientists confirmed this by looking at the plate's internal structure using CT scans. They found channels that could have only been for blood vessels, and the arrangement was perfect for rapid temperature changes. This wasn't just some passive defense system. It was an active part of Stegosaurus's survival toolkit. But if you think that's impressive, wait until you hear about dinosaur extinction, because everything you've been told about their disappearance being a failure of evolution, yeah, that's completely wrong. And the truth is gonna blow your mind. I am so sick of everyone thinking that dinosaurs were evolutionary failures. They ruled Earth for 165 million years. Humans, we've been around for about 300,000 years. That means dinosaurs dominated the planet 550 times longer than we have. Dinosaurs didn't just survive, they thrived. They evolved into everything from tiny feathered predators to the largest land animals that have ever lived. But here's the real mind bender. Dinosaurs are still here. Every time you see a bird, you're looking at a living dinosaur. That pigeon outside your window, it's got more dinosaur DNA than some dinosaurs had with each other. Birds aren't just the descendants of dinosaurs, they are dinosaurs, just as much as T-Rex or Velociraptor. Talk about successful. There are about 10,000 species of birds alive today. That's more species than all mammals combined. So not only did dinosaurs survive the asteroid impact, they're currently winning the diversity game. Not bad for a group that's supposedly extinct. The only reason we think of dinosaurs as failures is because we focused on the ones that didn't make it. That's like saying mammals are failures because saber-toothed cats went extinct. The truth is, dinosaurs were so successful even even a giant space rock couldn't completely wipe them out. So next time someone tells you dinosaurs were evolutionary dead ends, remind them that they're probably wrong about that too. Let's start with the biggest lie you've been told your entire life, that dinosaurs are extinct. Every textbook says dinosaurs died out 66 million years ago when that giant asteroid hit Earth, right? But here's the mind-blowing truth. Dinosaurs are everywhere. You probably saw at least 10 of them today. That's because birds aren't just related to dinosaurs. They are dinosaurs. Scientists have found that birds share specific skeletal features with dinosaur fossils, including that hole in the hip socket that defines all dinosaurs. When scientists tested protein sequences from T-Rex bones, they found that T-Rex was more closely related to chickens than to alligators. So that pigeon pooping on your car? Dinosaur. That chicken nugget you had for lunch? Dinosaur nugget. The only difference is that modern birds are the small flying dinosaurs that survived when their bigger cousins got wiped out. Every time you see a bird, you're literally watching a living dinosaur. But wait, what about all those other prehistoric creatures? You know, the ones with the weird sailing backs or the flying reptiles or those swimming monsters. Here's where toys and movies really mess up. Not everything big, prehistoric, and scary was a dinosaur. Take the Metrodon, that sailback creature everyone puts in dinosaur toy sets. It lived millions of years before dinosaurs even existed. Actually more closely related to mammals, like us, than to any dinosaur. Those flying pterosaurs from Jurassic Park, they're flying reptiles that evolved separately. And those giant sea monsters, creatures like mosasaurs and plesiosaurs were marine reptiles, totally different from dinosaurs. True dinosaurs were land animals with specific features like upright legs under their bodies. It's like calling a whale a fish just because it swims. Completely different animals. Now, if you're shocked that chickens are dinosaurs, wait and see what T-Rex actually looked like with its fabulous feather coat. Remember I was talking about those green scaly dinosaurs that every movie and toy has? Yeah, that's about as accurate as giving a penguin shark teeth. The truth about what dinosaurs actually looked like might be the biggest plot twist in science history. Since the 1990s, paleontologists have discovered hundreds of dinosaur fossils with clear impressions of feathers, especially in China. These weren't just a few weird fluffy dinosaurs either. We're talking about a huge number of species, particularly among the theropods, which includes T-Rex and Velociraptor. Take Eutyrannus, a relative of the T-Rex. This 30-foot predator was completely covered in feathers like a massive terrifying chicken. Even smaller dinosaurs like Sinoraptorix had a coat of fuzzy proto-feathers, kind of like dinosaur down. Scientists think these feathers first evolved for insulation or showing off to potential mates, way before birds used them for flying. And it wasn't just small dinosaurs or meat eaters either. We found evidence of feather-like structures on plant eaters like
STEGOSAURUS, Unintelligent
too. So next time you see a scaly velociraptor in a movie, just know you're actually looking at a naked dinosaur. It would be like showing humans without skin. Technically part of our anatomy, but not how we're supposed to look. But wait, it gets even better. Those dull gray and green dinosaurs you grew up with, pure imagination. Scientists can actually tell what color dinosaurs were by examining microscopic structures called melanosomes in fossil feathers. These tiny color-producing capsules survived for millions of years. Thanks to this discovery, we know that the Microraptor had iridescent black feathers that shimmered like a crow's. Anchinornis had a striking pattern of black, white, and reddish-brown feathers. Sinosopteryx had a striped tail and a raccoon-like mask. Some dinosaurs even had counter shading, darker on top, lighter underneath, just like modern animals use for camouflage. The dinosaur world wasn't just feathery, it was a rainbow explosion of color. T-Rex might have had bright patches for display or patterns for camouflage. The real prehistoric world looked more like a bird sanctuary than the drab reptile house we've been imagining in Jurassic Park. Hollywood seriously needs to update its graphics department. But now that you're picturing T-Rex as a giant rainbow chicken, let's shatter another myth about how these creatures actually moved. You know those old school museum displays of dinosaurs dragging their tails on the ground? Total garbage. Let's talk dinosaur tails. For decades, artists and museums showed dinosaurs with their massive tails dragging on the ground like giant lizards. It seemed to make sense. Those tails were huge, but when scientists studied fossil trackways, which are actual dinosaur footprints preserved in stone, they noticed something weird. There were no tail drag marks. None. Zero. In thousands of dinosaur tracks discovered worldwide, we don't see evidence of tails dragging. What we do see are footprints from animals balanced perfectly on their legs. It's because dinosaurs actually held their tails straight out behind them as a counterbalance to their heavy bodies and heads. Think about it like a seesaw. If you've got a heavy head up front, you need weight in the back to balance. Dinosaurs use their muscular tails as natural balance beams, keeping them horizontal and off the ground. This made them way more agile and efficient when moving. And speaking of wrong moves, let's talk about T-Rex's ridiculous kangaroo pose. Early museum displays showed T-Rex standing almost upright, with its tail on the ground almost like a third leg. Some even put it in a Godzilla-like posture. This made for scary movie monsters, but terrible science. Modern studies of T-Rex skeletons show its spine was meant to be horizontal, not vertical. The backbone, hip structure, and skull all line up in a way that only works if the dinosaur is balanced horizontally over its legs, with the tail extending straight back. Forcing a T-Rex into that upright posture would be like making you walk around with your spine bent 90 degrees. Painful and impossible. The real T-Rex walked with its body parallel to the ground, more like a giant bird than a kangaroo or a lizard. This position was much more stable and efficient for a predator weighing several tons. Think of it this way, T-Rex wasn't some slow tail-dragging monster. It was a perfectly balanced killing machine with a body designed for efficient movement. Those old museum displays weren't just wrong, they were physically impossible. If Hollywood messed up something as basic as how dinosaurs stood, imagine what they got wrong about T-Rex's senses in hunting. So remember that scene in Jurassic Park where they say, "Don't move. T-Rex can't see if you don't move." That might be the biggest lie Hollywood ever told about dinosaurs. If you actually tried the stand still trick with a real T-Rex, you'd become dino dinner faster than you could say clever girl. Here's why. T-Rex had some of the best vision in the dinosaur world. Scientists studying T-Rex skulls found it had massive eye sockets the size of grapefruits. Those huge eyes weren't just for show. They gave T-Rex incredible vision that would put your eyesight to shame. T-Rex had forward-facing eyes like a hawk, giving it excellent depth perception for judging distances. Pretty important when you're trying to chomp moving prey. But this is where it gets interesting. Studies suggest T-Rex's visual acuity was up to 13 times better than humans. That means it could distinguish objects with incredible precision, possibly even better than modern eagles and hawks. It could accurately judge exactly how far away you were while standing perfectly still. So the next time someone tells you to stand still around a T-Rex, remember, that's like trying to hide from an eagle by freezing in an open field. Good luck with that strategy. But that's not the only T-Rex myth that science has crushed. Some paleontologists once suggested that T-Rex was just a giant scavenger, too slow and clumsy to hunt live prey. They claimed it just bullied smaller predators away from their kills, like a prehistoric vulture with attitude. The evidence completely destroys this idea. T-Rex had a bone-crushing bite force powerful enough to shatter the bones of its prey. That's not an adaptation you need for eating already dead animals. Even more convincing, scientists have found healed T-Rex bite marks on Triceratops and Edmontosaurus bones, which is absolute proof that the T-Rex hunted live animals. T-Rex was the ultimate apex predator of its time. Like modern lions or wolves, it probably scavenged when convenient. Hey, like free food is free food. Are you gonna give it up? But make no mistake, it was a killer, not just a cleanup crew. But here's what most people miss about it. T-Rex was a super powerful predator with eagle vision. But what you've heard about how fast it could run will make your jaw drop. Remember that Jurassic Park scene with the Jeep chase? It's time for a reality check on T-Rex speed. So how fast could T-Rex actually run? The answer isn't as simple as slow or fast. For years, scientists argued about this. Some said a creature so massive could barely manage a quick walk, while others claimed it could sprint like a giant, terrifying ostrich. The truth is somewhere in the middle. T-Rex wasn't a slowpoke, but it definitely wasn't chasing down Jeeps at highway speeds either. Modern studies looking at leg bones, muscle attachments, and body weight suggest T-Rex could reach speeds between 10 to 25 miles per hour. Think somewhere between a jogging human and a running elephant. That's pretty fast to catch prey like Triceratops or duck-billed dinosaurs, which weren't exactly speed demons themselves. And baby T-Rexes, they were built lighter and probably much faster than the adults. So could you outrun a T-Rex? Maybe if you're a serious athlete. The average person? Not a chance. It would catch you before you could even finish screaming. Now let's talk about another bizarre dinosaur movement myth, the bunny hands problem. Take a look at most dinosaur toys, pictures in books, and even museum displays, and you'll see carnivorous dinosaurs with their hands facing palms down, like they're ready to push their triceps in the gym. Scientists call this the broken wrist pose because it's completely impossible. Here's the deal. Theropod dinosaurs physically couldn't rotate their wrists that way. Their anatomy prevented it. Forcing a T-Rex hand into that position would be like twisting your arm until something snaps. Instead, their hands naturally face each other, palms inward, like they were about to clap. Think of it as a permanent give me a high five position. This makes sense for grabbing prey, not pushing things around. Every time you see a dinosaur toy with downward facing palms, that dinosaur has dislocated wrists. Ouch. This might seem like a small detail, but it completely changes how we understand dinosaur behavior. Those mighty arms weren't for pushing. They were for grabbing and holding. But here's what most people miss. The dinosaur lies get even weirder when we look at bizarre myths about what specific dinosaurs could actually do with their fancy headgear. Have you ever seen those giant long-necked dinosaurs like Brachiosaurus with nostrils on top of their heads? That bizarre feature shows up in books, movies, and museum displays, but it's completely made up. For decades, scientists thought sauropods had their nostrils on top of their heads because that's where the large hole is in their skull. Early paleontologists even suggested they used them like snorkels when hanging out in deep water. But modern research tells a totally different story. When scientists studied the inside of sauropod skulls, they found tiny marks where blood vessels and nerves attached. These marks are always near the front of the snout, not on top of the head. Plus, almost every animal alive today, from birds to crocodiles, has its fleshy nostrils at the front of the face, regardless of where the bone opening is. The large opening on top wasn't a nostril at all. It was just the beginning of a bigger nasal cavity that might have helped with cooling their massive bodies or making sounds. Real sauropods have their nostrils right at the front of their face, just like we do. And speaking of bizarre head features, let's talk about a parasaur, the duck-billed dinosaur with a huge curved tube on its head. Some truly wild theories suggest it used that crest as a snorkel for breathing underwater. Others, including one creationist scientist, actually proposed it could breathe fire like a biblical dragon. Yeah, both ideas are hilariously wrong. For starters, the tube is completely closed at the end, so it would be the worst snorkel ever. And as for fire breathing, yeah, there's zero evidence of any mechanism that could produce flames. No animal alive today can breathe fire, and nothing in the parasaur's skull suggests it could either. The truth is much cooler actually. The crest contained long, winding nasal passages that worked like a natural trumpet or trombone. Scientists who created computer models of the crest found it could produce deep, resonating sounds, perfect for communicating across long distances or attracting mates. Imagine a whole herd of these dinosaurs making low, booming calls that echo miles. The crest was basically a built-in mute instrument and a fancy billboard advertising, "Hey, check me out," to potential mates. Now, if you think dinosaur nose myths are weird, wait till you hear how wrong we've been about where and how these massive creatures actually lived. So those massive long-necked dinosaurs were too heavy to walk on land, right? That's why old books always showed Brontosaurus and friends hanging out in lakes and swamps, using water to support their enormous weight. Well, spoiler alert, completely wrong. This idea was super popular in the early days of paleontology. Scientists looked at those giant sauropods weighing up to 70 tons and thought, no way these beasts could support themselves on land. Some even thought the high nostril position, which we just debunked, was like a built-in snorkel. And this is all part of the same theory. But actual evidence tells us sauropods were fully land-dwelling creatures. Their legs were arranged in sturdy, column-like structures similar to modern elephants, perfectly designed for supporting massive weights on solid ground. Their feet had special pad structures that worked like built-in shock absorbers, just like elephant feet today. The most convincing proof comes from fossil trackways, preserved footprints that show sauropods walking on dry land, not swimming or floating. These giants definitely visited water to drink or cool off, but they didn't need it to stay afloat. They were basically the prehistoric equivalent of elephants, huge, but perfectly adapted for life on land. The whole too heavy for land myth is like saying elephants would collapse under their own weight without swimming pools. Speaking of dinosaurs in water, let's talk about Spinosaurus, the sailback predator that's been rewritten more times than a Hollywood script. Recent discoveries had some scientists claiming Spinosaurus was basically a dinosaur crocodile, actively chasing prey underwater like an Olympic swimmer. Evidence seemed impressive: dense bones like penguin bones, a paddle-like tail, crocodile-like teeth, and a body shape unlike other dinosaurs. Some declared it the first fully aquatic dinosaur, but not so fast. New research shows Spinosaurus would have been a terrible swimmer if it only lived in water. Its massive sail would have created huge drag underwater, making it unstable and slow. Its tail can generate enough power for chasing fish, and its lungs would have made it too buoyant to easily dive. In reality, Spinosaurus is more like a giant heron or a bear fishing at a riverbank, a wading predator that hunted from the shoreline, occasionally swimming in at the surface, but not diving to chase prey underwater. Still incredibly specialized for a dinosaur, just not the underwater pursuit machine some claimed. So yes, it was deadly in the water, but only on the shore. But that brings me to another myth. Do you think dinosaurs were just mindless eating machines? Well, the truth about dinosaur intelligence and parenting skills would completely change how you see these ancient animals. We still use the word dinosaur as an insult for something outdated or stupid, but calling someone a dinosaur because they're dumb, science says that's actually pretty stupid itself. For decades, people thought dinosaurs were just giant lizards with walnut-sized brains. slow, dumb, and doomed to extinction because they couldn't adapt. This myth partially came from creatures like Stegosaurus, which had a brain roughly the size of a dog's despite weighing as much as a bus. But dinosaur intelligence varied enormously. Some, particularly smaller theropods like troodontids and velociraptors, had relatively large brains compared to their body size. Their brain-to-body ratio approaches that of modern birds, which we know are pretty smart. Crows can solve puzzles, mockingbirds remember human faces for years, and parrots understand basic language. This is where it gets interesting though. Scientists have also found evidence of complex dinosaur behaviors, hunting in packs and living in herds with social structures. These aren't things stupid animals typically do. Now, were dinosaurs solving calculus problems or building dinosaur cities? No, but they weren't mindless eating machines either. They successfully dominated Earth for over 150 million years. That's about 149.9 million years longer than humans have existed. You don't rule the planet that long by being stupid. Speaking of smart behaviors, let's talk dinosaur parenting. Movies often show dinosaurs laying eggs and abandoning them, but that's another major myth. In Montana, scientists discovered a nesting group of duck-billed dinosaurs they named Maiasaura, which literally means good mother lizard. These nests contain eggs, babies, and juveniles of different ages. The worn-down teeth in the babies suggest parents were bringing food to the nest, which is basically like dinosaur DoorDash. Even more amazing was the discovery of dinosaurs that died while sitting on their nests. Several Oviraptor fossils have been found in brooding position, literally giving their lives to protect their eggs from sandstorms or predators. Scientists have discovered extensive nesting colonies showing that many dinosaurs return to the same nesting sites year after year, just like modern birds. Some may have even nested in groups for protection, basically creating a prehistoric dinosaur daycare. This sophisticated parental care is light years away from the lay 'em and leave myth that we've been told. But now let's talk about our last two myths. We all know the story. One day, a giant space rock smashed into Earth and boom, all the dinosaurs died instantly. Simple, right? Well, not exactly. The real extinction story is way more complicated and even more terrifying. Yes, a massive asteroid did hit Earth about 66 million years ago, creating the crater we all know in modern-day Mexico. But that wasn't the only disaster happening. At the same time, some of the biggest volcanoes ever were erupting in what's now India, spewing out toxic gases and changing the climate even before the asteroid hit. And here's another shocker. The extinction wasn't instant. While the impact itself caused immediate devastation with massive tsunamis, wildfires, and an impact winter where dust basically blocked the sun. On the other hand, the full extinction process likely took thousands of years. This is where it gets interesting though. You gotta think of it like a domino effect. First, plants couldn't grow without sunlight, then plant eaters starved, then the meat eaters that hunted them died out. The whole food web was collapsed step by step. It was a slow motion apocalypse. And it wasn't just bad luck. Some animal groups survived while others perished. Birds, which are avian dinosaurs, mammals, crocodiles, turtles, and many others made it through. It wasn't random. Certain adaptations helped some animals survive while others perished. Speaking of survival, let's talk about the biggest dinosaur myth created by Hollywood. The idea that we could clone dinosaurs from ancient DNA, like in Jurassic Park. In the movies, scientists find dinosaur blood in mosquitoes trapped in amber, extract the DNA, and use it to clone extinct dinosaurs. It sounds plausible enough that many people believe it could actually happen. The problem? DNA starts breaking down immediately after death. Even under perfect conditions, DNA has a half-life. It breaks into smaller and smaller pieces over time. Scientists estimate that readable DNA sequences are completely gone after about 1 to 1.5 billion years max. Dinosaurs went extinct 66 million years ago. That's at least 65 billion years too late for viable DNA. So even the mosquitoes in amber wouldn't help. The DNA inside them would have degraded too, and finding a complete dinosaur genome from tiny fragments is mathematically impossible. But recently we did just clone direwolves, so never say never. Although they're not a one-to-one clone of the direwolf, and it's also a much more recent animal that went extinct, so that's why they had enough DNA to make it. But who knows in the future what will happen. The closest we'll likely ever get to seeing real dinosaurs is by studying their living descendants, birds. So next time someone tells you Jurassic Park could really happen, just point to the pigeon outside your window and say, that's as close as you're getting to a velociraptor. Remember those dinosaur books you had as a kid? Well, like I said, they were lying to you. It started with the very first dinosaur scientists ever discovered. Back in the 1820s, a doctor named Gideon Mantell found some weird teeth and bones in England. He had no complete skeleton, just random parts. When he found a pointy bone spike, he thought that must be a horn that goes on its nose. I mean, it made sense at the time. Rhino iguanas have nose horns, so why not this iguana-toothed dinosaur? They named it Iguanodon, and for over 50 years, every drawing showed it with a horn on its nose. But here's where it gets crazy. In 1878, miners in Belgium found a whole bunch of complete Iguanodon skeletons. And guess what? That nose horn was actually a thumb spike. Imagine having a giant spike on your thumb. For 50 years, scientists had the dinosaur equivalent of putting your shoes on the wrong feet, but way worse. They basically put the dinosaur's thumb on its face. It's like if aliens found human skeletons and decided our thumbs belonged on our foreheads. But you think that thumb nose mix-up was bad? Hold my prehistoric beer. Megalosaurus was the very first dinosaur ever named by science in 1824, but they had almost nothing to work with. Just a piece of jawbone and some other fragments. So what did they think it looks like? They thought it looked like a massive four-legged lizard. They literally called it Great Lizard and thought it was just a scaled-up version of modern leopards. A huge, slow beast lumbering around on four legs. Famous scientist Richard Owen even built a life-sized model of it for the Crystal Palace in 1854, where thousands of people saw it and thought, yep, that's definitely what dinosaurs looked like. But imagine their surprise if they saw what we know today. Because Megalosaurus was actually a fierce two-legged predator. It stood upright on powerful back legs with a horizontal body balanced by its tail and had smaller arms. It's like if you thought a T-Rex was basically just a giant iguana. Not even close. Scientists figured this out when they found more complete skeletons of similar dinosaurs. The whole dinosaurs are giant lizards idea was completely wrong, and these embarrassing mistakes were just the beginning. Some dinosaur mix-ups were still messing with museum displays as well into the 1970s. Because imagine waking up tomorrow with someone else's head on your body, because that's basically what happened to Apatosaurus for almost half a century in museums across America. The Carnegie Museum of Natural History found an amazing Apatosaurus skeleton around 1909. Just one tiny problem. They couldn't find its head. Awkward. Well, what did they do about it? For years, they actually displayed this massive dinosaur without a head, because apparently a headless dinosaur was better than no dinosaur. But wait, it gets weirder. In 1934, they finally got tired of their headless dinosaur and put a head on it. Just one problem, they used the wrong head. They gave poor Apatosaurus a Chimaerosaurus skull, which is a completely different dinosaur. It's like putting a hippo's head on a giraffe and saying, close enough. This wasn't just one museum. This mistake spread everywhere afterwards. The truth didn't come out until the 1970s when scientists realized Apatosaurus actually had a much smaller, horse-like head. On October 20th, 1979, the Carnegie Museum finally gave Apatosaurus its real head back after 45 years of having an identity crisis. Imagine being arrested for breaking into your own house. Well, that's basically what happened to Oviraptor. In 1923, scientists found a dinosaur skeleton right next to a nest of eggs in Mongolia. They immediately assumed the worst. This dinosaur died while stealing and eating eggs from another dinosaur's nest. They even named it Oviraptor, which literally means egg thief. Talk about being framed. What was it actually doing though? Well, I'm about to tell you. For 75 years, Oviraptor had this terrible reputation. All the books called it a nest robber. Every museum display showed it sneaking around stealing eggs. Poor Oviraptor was the villain in every dinosaur story. But here's the twist that changes everything. In the 1990s, scientists found more nests with the exact same type of eggs. Inside those eggs, baby Oviraptors. This wasn't a criminal caught in the act. This was a parent protecting its own nest. The original Oviraptor was likely sitting on its eggs, keeping them warm, maybe even dying in a sandstorm or refusing to abandon its babies. It's literally the most devoted dinosaur parent we know of, and we gave it a name that means egg thief. Talk about the worst case of a mistaken identity in history. Justice for the Oviraptor. Free my boy. Or my girl, I guess. At least these creatures were actual dinosaurs, unlike some imposters that have been fooling you for your entire life. Because when I was a kid, science books taught me that there were two main groups of meat-eating dinosaurs. Big ones called Carnosaurs and smaller ones called Coelurosaurs. Simple, right? If it was big and scary with teeth, it was a Carnosaur. Allosaurus, Tyrannosaurus, Spinosaurus, Carnotaurus, all thrown in the same group because they were big predators. But modern science is a message for those old books. Yeah, that's not how evolution works. Here's the shocking truth. Tyrannosaurus rex isn't a carnosaur at all. It's actually a Coelurosaur, the same group as the small dinosaurs, and the same group that includes birds. True carnosaurs today include only Allosaurus and its close relatives. Spinosaurus belongs to a completely different group, and Carnotaurus belongs to yet another separate branch. It's like if we were grouping lions, bears, and hyenas together just because they're all big predators, when they're actually not closely related at all. These dinosaurs independently evolved to become large predators multiple times. Nature is way more complex and awesome than big scary dinosaurs go in one group, small ones in another. Evolution doesn't work that way. It branches like a tree, not like your school's lunch menu categories. Now that we know what isn't a dinosaur, let's talk about how dinosaurs actually functioned inside their scaly, or maybe not so scaly, bodies. So you probably learned in school that mammals and birds are warm-blooded and reptiles and fish are cold-blooded, right? And since dinosaurs look like reptiles, they must be cold-blooded too. Simple, except it's not simple at all. It's actually one of the biggest oversimplifications in science ever. For decades, scientists have been fighting about whether dinosaurs were warm-blooded like birds or cold-blooded like lizards. And guess what? They were probably neither. Wait, what? Yeah, that's right. Modern research shows many dinosaurs were likely something in between, what scientists call mesotherms. Think of animals like tuna or great white sharks. They're warmer than the water around them, but don't maintain a perfect body temperature like we do. And those massive sauropods, the ones bigger than school buses, they stayed warm just because they were so huge. It's called gigantothermy. When you're that big, your body holds heat naturally. It's like how a cup of coffee cools down faster than a whole pot. The biggest revelation? Different dinosaur groups probably had completely different metabolisms. Some more bird-like, some more reptile-like, and others something totally unique. That's because nature doesn't care about our simple categories. Dinosaurs were too busy being awesome to fit in our neat little boxes. And you might think dinosaurs grew steadily throughout their lives, just getting a little bigger each year until they reached adult size. Makes sense, right? Well, did they really grow this way? Nope. When scientists cut open dinosaur bones, don't worry, they're fossils, they can see growth rings, kind of like tree rings, and what they found completely changed how we see dinosaur lives. Here's the mind-blowing part. Many dinosaurs had absolutely insane teenage growth spurts. We're talking T-Rex gaining up to 5 pounds per day during its teenage years. It's like if you grew from the size of a chicken to the size of a rhino in just a few years. Imagine how much food you'd have to eat to support that. And it wasn't just T-Rex. Scientists found that dinosaurs like Maiasaura would grow super fast during good times, then almost stop growing during tough seasons. Their bones literally record good years and bad years in them. Even weirder, different parts of their bodies grew at different rates. The Ceratopsian PTEROSAURUS started life walking on 4 legs, but its back legs grew faster than its front legs, so adults walked on 2 legs. Their insides weren't what we thought, and neither were their outsides. Those iconic dinosaur features you recognize? Yeah, they weren't what they seemed either. Cause you know those awesome neck frills on Triceratops and other horned dinosaurs? The ones that look like built-in shields? Every dinosaur book says they evolved as armor against predators like T-Rex. It makes perfect sense, and it's probably wrong. I mean, Triceratops did have a solid frill that could have offered some protection, but most other ceratopsians, their frills were full of holes. What kind of useless shield has giant holes in it? It's like wearing a bulletproof vest made of Swiss cheese. Well, that's because the truth is way more interesting. Those frills were likely the dinosaur equivalent of peacock tails, giant billboards for showing off to mates. Here's how we know. The frills and horn patterns were wildly different between species, even ones that lived in the same places at the same time. If they were just for defense, they'd all look similar, but they were as unique as fingerprints. Even better evidence, the fancy frills only fully developed when the dinosaurs reached sexual maturity, exactly when they need to start attracting mates or intimidating rivals. Scientists think these frills might have been covered in skin and possibly brightly colored. Imagine Triceratops with a frill like a toucan's beak or a mandrill's face. These weren't just battle tanks, they were prehistoric peacocks trying to look fabulous. When you look at Ankylosaurus, you know, the dinosaur that looks like a walking tank with club tails, you might think, wow, their heads are completely covered in armor. They probably couldn't smell much with all that bone in the way. I mean, it makes sense. Their entire bodies were covered in armor plates, and their heads look like living battering rams. How good could their noses possibly be? Well, get ready to have your mind blown. CT scans of Ankylosaurus skulls show they actually had an amazing sense of smell, possibly one of the best in the dinosaur world. The olfactory bulbs, which is the brain parts that process smell, were huge compared to the rest of their brain, and their nasal passages, super long and complex with tons of twists and turns inside their skulls. It's like they had a bloodhound's nose inside of a tank's body. This incredible sense of smell probably helped them find food, detect predators from far away, and maybe even recognize other ankylosaurs. So that armor didn't make them sensory deprived at all. It's like how blind people often develop better hearing. When you're that heavily armored, maybe a super sniffer is your evolutionary compensation package. But these armor-plated sniffers weren't the only dinosaurs we've been picturing all wrong. Let's dive into some habitat myths that'll make you question everything you've seen in Jurassic Park. If you've seen duck-billed dinosaurs in older books or movies, they're almost always shown splashing around in swamps or lakes. They have duck-like bills, so they must be semi-aquatic, right? Scientists even thought they had webbed feet for swimming because apparently, if it looks somewhat like a duck, it's gotta be a duck. From the 1800s until the 1960s, everyone assumed hadrosaurs were basically prehistoric swamp ducks, using their flat bills to eat soft water plants and swimming away from predators. It made perfect sense. Except it was completely wrong. When scientists finally found hadrosaur mummies, which are fossils with skin impressions, they discovered something shocking. Their hands weren't webbed at all. They had fleshy pads, kind of like what elephants have. Their feet, not duck-like, but with 3 broad hoof-like toes, perfect for walking on land. We even have their footprints to prove it. And those flat duck bills, they contain thousands of teeth packed together into dental batteries, which are grinding machines for tough land plants, not soft water weeds. But the nail in the coffin for the swamp theory, their tails were super stiff, terrible for swimming, but perfect for balance while walking on 2 legs or running from predators. These weren't swamp ducks, they were the cows of the Cretaceous, grazing their way across plains and forests. Speaking of cows, when we see dinosaur herds in movies, they're always shown acting like elephants or bison, with protective circles, clear leaders, and complex social behaviors. But how could we possibly know all of that from fossils? Don't get me wrong, we do have solid evidence that many dinosaurs lived in groups. We found massive bone beds with hundreds of individuals that died together. We have trackways showing multiple animals walking side by side, but that's where the facts end and the imagination begins. This is where it gets interesting. We simply don't have fossil evidence for specific behaviors like protective formations, male versus female roles, or herd leadership. That's all guesswork based on modern animals. What we do know is that many dinosaurs were social. The Egg Mountain site shows dozens of Maiasaura nests close together, suggesting they nested in colonies. Trackways in Texas and Colorado show sauropods moving in the same direction, sometimes with bigger individuals on the outside. But the details of dinosaur social life, that's still mostly a mystery. We can say they hung out together, but we can't say they had the same social structures as modern African mammals just because it makes for good documentaries. It would be like aliens finding a subway station full of human skeletons and concluding we had the same social structure as honeybees. Maybe we did, maybe we didn't. Fossils can only tell us so much. So yeah, speaking of things documentaries and movies get wrong about dinosaurs, let's talk about the sounds that haunted your childhood nightmares. You remember that bone-chilling T-Rex roar from Jurassic Park? Well, that sound kept me and multiple other kids awake for years. But here's the thing, that iconic sound is probably the biggest lie in dinosaur movies. Movie sound designers created those roars by mixing lion, alligator, and elephant sounds. But dinosaurs aren't related to mammals. They're related to birds and crocodiles. This is where it gets fascinating. Scientists studying dinosaur anatomy found no evidence they could roar like lions. They didn't have the same kind of voice box, which is called a larynx, that most mammals use to roar. And birds, which are living dinosaurs, use a completely different sound-making organ called a syrinx. So what did T-Rex actually sound like? Probably more like rumbles and hisses of crocodiles mixed with low-frequency sounds, like emus or cassowaries. That deep, booming sound might be closer to reality. Like some dinosaurs, like the hollow-crested parasaur, had built-in sound chambers that probably made loud, low trumpet-like calls. Think elephant meets tuba, not lion meets nightmare. Hollywood gave us scary movie monsters. Reality gave us something even weirder. Dinosaurs that probably sounded like a bizarre mix of birds and alligators, which honestly is way cooler than just big lizard roar. You've probably also heard that scientists can tell a dinosaur's age by counting rings in their bones, just like tree rings. 1 ring equals 1 year, right? Simple math. It's a cool idea, and it's partially true. These rings are called lines of arrested growth, or LAGs, and they do form annually when growth slows during tough seasons. Cut open a dinosaur leg bone, count the rings, and boom, you know how old it was. But here's the surprising problem. Counting these rings usually gives you the minimum age, not the exact age. Why? Because dinosaurs were constantly remodeling their bones from the inside out, kind of like how we renovate old homes. What do I mean? Well, the earliest rings from when they were babies and toddlers often get completely erased as the bone grows. So T-Rex might show 20 rings, but actually have lived for 28 years. Those first 8 years, the evidence is gone. But it gets even trickier. Some dinosaurs grew so fast as babies that they didn't form clear rings at all. Others have different ring counts and different bones of the same body. It's like trying to figure out someone's age when they've torn the first few pages out of their diary and scribbled over their birth certificate. Scientists have to become bone detectives, using math and models to estimate the missing years. But now let's leave actual dinosaurs behind and talk about the flying reptiles everyone wrongly calls dinosaurs. And trust me, everything you think you know about them is wrong too. When you see pterosaurs, which are those flying reptiles from the dinosaur times, in movies or books, they always have these bat-like leathery wings. They're basically flying lizards with naked skin stretched between their fingers and body. This image is so common that it's in basically every dinosaur book ever made. It makes sense, right? They're reptiles. Reptiles have scales. Done. But wait, we've got a reality check coming. Exceptionally preserved fossils from Germany and China show that pterosaurs were actually, wait for it, fuzzy. Their entire bodies, including their wings, were covered with hair-like structures called cynofibers. That's right, these weren't naked leather wings, but fluffy, fuzzy wing membranes. Think less flying lizard and more like a flying koala. It's like my dog Flapjack. They'd be fuzzy like he is. Say hi. These cynofibers weren't exactly the same as mammal hair or bird feathers, but they served similar purposes: insulation, aerodynamics, and possibly display. And they completely change how we should picture these animals. Imagine all those pterosaur toys you had as a kid. Now add fuzzy coating to every single one of them. That's right, your Jurassic World pterosaur action figure is a lie. It should be fuzzy and cute, not leathery and scary. But that doesn't necessarily mean they're not dangerous. Speaking of pterosaurs, for decades scientists argued about whether pterosaurs, especially the giant ones, could actually fly or just glided from high places. I mean, some pterosaurs had wingspans over 30 feet. That's wider than many small planes. It seems impossible that something that big could take off from the ground and actively flap those massive wings. The shocking answer is, not only could pterosaurs fly, but they were amazing at it. They weren't just gliders, they were active, powerful flyers that could probably take off from flat ground and fly for extremely long distances. The evidence? It's in their bones. Though hollow like birds, they were incredibly strong. They had massive breastbones, which are called sternums, where powerful flight muscles were attached. Their shoulder joints were perfectly designed for the full range of motion needed for flapping flight. Even the biggest pterosaurs, like the Quetzalcoatlus, with its school bus-sized wingspan, had the proper bone structure for powered flight. They probably used a combination of flapping for takeoff and control, then soaring to conserve energy, like modern albatrosses do. So the next time you see a movie where pterosaurs only glide down from cliffs, you can say, actually, these weren't prehistoric hang gliders. They were the most efficient flying machines ever evolved. But if pterosaurs were such incredible flyers, could they really snatch up humans like in the movies? Well, let's destroy another pterosaur myth you probably believe. Every movie with pterosaurs has that scene. A giant pterodon or Quetzalcoatlus swoops down, grabs a screaming person with its talons or its beak, and then carries them off into the sky. Terrifying, right? It's the perfect movie monster moment. But like most movie monster moments, it's complete nonsense. Here's the truth that ruins the fun. Pterosaurs did not have eagle-like grasping feet. Their feet were built for walking on the ground, not grabbing prey. Unlike birds of prey with their powerful opposable talons, pterosaurs had weak feet with straightish toes and small claws. Most importantly, they lacked the opposable thumb toe, which is called the hallux, that eagles and hawks use to create that powerful grip. Large pterosaurs like the pterodon would have had about as much grasping power in their feet as a chicken. Imagine a chicken trying to pick you up. Not very scary, but don't get me wrong, I am a little terrified of chickens. I grew up on a farm and we had chickens as a kid, and chickens are pretty vicious. If you've never had chickens around you before, don't mess with chickens. They might come after you. The largest pterosaurs, like Quetzalcoatlus, spent considerable time walking on all fours on the ground, using their wings like front legs. Their feet were built for supporting their weight, not dangling prey beneath them. Sorry, Hollywood, pterosaurs weren't flying kidnappers. If you saw one, you'd have more to fear from its beak than its feet. Speaking of beaks, if you check your old dinosaur toys or books, chances are the pterosaur labeled pterodon has a mouth full of pointy teeth. It makes sense, it's a prehistoric flying reptile, so of course it has scary teeth for catching fish and scaring children, right? Even some museum displays got this wrong for decades. But here's the fun fact. The name pterodon literally means wing without tooth. That's right, the word toothless is built right into its name. Pterodon had a completely toothless beak, probably covered with a horny sheath like modern birds. Other pterosaurs, like the Rhamphorhynchus, did have teeth, which is probably why people get confused. This toothless bill was perfectly adapted for catching slippery fish from the water. No teeth meant less drag and faster closing speed, which is ideal for a fishing specialist. So every time a movie or toy shows pterodon with teeth, they're not just getting a detail wrong, they're literally contradicting the meaning of its scientific name. It's like making a toy bluebird that's bright red. It had one job. But flying reptiles weren't the only prehistoric creatures people constantly confuse with dinosaurs. Let's talk about those long-necked sea monsters next. If you've ever seen a picture of plesiosaurs, which are those long-necked marine reptiles, they're almost always shown with their necks arched elegantly out of the water like swans. This swan-like pose is so common, it's basically the standard Loch Ness monster look, and it seems logical. Why have such a long neck if not to stick it up way out of the water? But here's the neck-breaking truth. Plesiosaurs physically couldn't hold their necks in that swan-like pose. Their neck vertebrae and muscles simply weren't built for it. Studies of their neck bones show that they can move their necks side to side pretty well, but trying to bend it up in that classic swan pose would be like you trying to touch your ear with your shoulder blade. Physically impossible without breaking something. Plus, their necks were heavy. Imagine holding a 20-foot pole straight out from your body. Now make it weigh hundreds of pounds. No muscles could keep that position against gravity for more than a few seconds. So what were those super long necks actually for? Probably for sneaking up on fish from below or reaching into crevices, all while keeping their bulky bodies hidden. Think more underwater snake than prehistoric swan. Sorry Loch Ness Monsters fans, if plesiosaurs somehow survived to modern times, they wouldn't be poking their heads up for tourist photos. Which sucks because it's one of my favorite dinosaurs. It's not actually a dinosaur, it's a marine reptile. Now let's leave the water behind and bust some myths about the world dinosaurs lived in, which wasn't nearly as alien as you might think. Picture a dinosaur habitat. What do you see? Probably ferns, cycads, some weird prehistoric trees, but definitely not grass. Every documentary and textbook tells us grass came later, after the dinosaurs were long gone. For some reason, we got in our heads that dinosaurs did not live when grass was around. If you look at most dinosaur documentaries, you won't see the dinosaurs walking through grass. Well, get ready for a prehistoric lawn makeover. Dinosaurs did live alongside grass. Scientists found grass pollen in fossilized dinosaur poop from the late Cretaceous period. That's right, some of the last dinosaurs to walk the earth were literally pooping out grass. Specifically, scientists found grass remains in Titanosaur coprolites, which is fossilized poop from India, dating to just before the extinction event. Now, it wasn't the vast grasslands we see today. Those did evolve later, but patches of early grasses were definitely part of the dinosaur world. Some titanosaurs, which are the massive long-necked sauropods, were actually grazing on it, kind of like a cow does. So next time you see a dinosaur documentary with absolutely no grass anywhere, you can say, actually, some dinosaurs were literally leaving grass stains on their feet. But enough talking about the big titanosaurs. Let's talk about a little guy. Archaeopteryx is probably the most famous transitional fossil ever found. This crow-sized creature with feathers, wings, and teeth was discovered just 2 years after Darwin published his theory of evolution. For over 150 years, it's been presented either as the missing link between dinosaurs and birds, or from evolution deniers as a complete hoax with fake feather impressions added to a dinosaur skeleton. Both views can't be right, but guess what? They're both wrong. Here's the fascinating reality. First off, Archaeopteryx is 100% genuine. Multiple specimens exist, all showing the same features. Microscopic examination confirms the feather impressions are authentic and formed at the same time as the bones fossilized. But it's not the direct ancestor of modern birds. It's more like an early side branch of the bird family tree, a cousin to bird ancestors, not your great-great-grandbird. We've now found dozens of other feathered dinosaurs, some more bird-like, some less, showing that the dinosaur to bird transition wasn't a straight line, but a bushy tree with lots of branches. Creatures like the Microraptor, Anaconornis, and the Sinosopteryx give us a much more complete picture. Evolution doesn't work like a ladder, with Archaeopteryx as the halfway point between dinosaurs and bird. It's more like a shrub, with Archaeopteryx as just one of the many twigs. A cool one for sure, but it's not the link. Now let's talk about two massive myths about dinosaur extinction and dinosaur size that a lot of people still believe. After the asteroid hit Earth 66 million years ago and wiped out the non-bird dinosaurs, something weird happened in the fossil record. Suddenly, fern spores are everywhere in the rock layers, while other plant pollens nearly disappear. Most books explain this simply. Ferns are tough pioneers that quickly took advantage of the cleared landscape. Which, easy explanation, ferns are just naturally tougher than other plants, right? Well, no, there's actually a much cooler story here. This fern spike wasn't just ferns being naturally tough. It represents an entire ecological recovery process that may have lasted thousands of years. After the impact, the world faced a nuclear winter-like scenario. Dust blocking sunlight, acid rain falling, temperatures fluctuating wildly. In this apocalyptic landscape, ferns had specific superpowers. First, they produce massive amounts of tiny spores that travel far on the wind, perfect for reaching isolated areas. Second, fern spores grow into a tiny, independent plant stage that can survive in horrible conditions. And many ferns had underground stems that could survive even when everything above ground was burning. Scientists even found a fungal spike before the fern spike, which is evidence of widespread death and decay. Then came the ferns, nature's first responders to global disaster. They ruled for 1,000 to 30,000 years before forests could recover. It's not just ferns are tough, it's ferns have the perfect apocalypse survival strategy. So when all of us are long gone, you know who will still be around? That fern in your backyard. Here's probably the strangest myth that I used to believe as a kid. Have you heard this one? Dinosaurs could only get so big because Earth's gravity was weaker back then. It sounds scientific, and it seems to explain how creatures as massive as Argentinosaurus could possibly walk without collapsing. This idea pops up regularly on social media and even in some documentaries. I mean, how else could animals that weighed as much as 10 elephants support themselves? Well, time for some physics reality. Earth's gravity hasn't changed significantly in the last several hundred million years. There's absolutely no evidence or mechanism for how Earth could have lost or gained enough mass to meaningfully change its gravitational pull over dinosaur timescales. The moon's orbit, which is extremely sensitive to Earth's mass, shows no signs of major gravitational changes during this period. If gravity had been significantly weaker, it would have affected everything, not just the dinosaurs. So that leaves the question, how did dinosaurs get so massive? Well, it's through incredible biological adaptations. Their bones were full of air spaces, making them lighter without sacrificing strength. Their breathing system, like modern birds, was super efficient. Their pillar-like legs, positioned directly under their bodies, could support tremendous weight. And dinosaur footprints show that they walked at speeds consistent with our current gravity, not the slow-motion movement you'd expect if gravity suddenly increased after their time. Dinosaurs weren't aliens benefiting from weird physics. They were biological marvels that evolved perfect solutions for growing massive under the exact same gravity we experience today. So you have it, a bunch of dinosaur myths completely destroyed by science. Honestly, if there's anything I learned from this video, it's that the truth is even more strange than fiction. If you enjoyed this video and you learned something new, I want you to like and subscribe to the channel, because I talk a lot about dinosaurs and dinosaurs from movies on this channel a ton. And if you want to watch another video just like this, where I break down more dinosaur myths, you can click on the screen right now.